Am I audible to you guys? Yes, yes, I am audible to you guys with an S here. So before we go further, I want all of you guys to remember one thing. I know these are tough times. So as you can see, the second wave is here. Okay, second wave of Corona is here. So I want all of you guys to stay at home and stay safe. Don't roam around outside. You see, US and Europe, their second wave is full on going on there. So keep your distance like this guy here is doing it. Stay at home, stay safe, wash your hands regularly, and also happy Diwali in advance. So while staying at home and staying safe, crack IIT-JEE with India's largest platform, which is Unacademy. Get the Plus subscription to access unlimited live and recorded courses from India's best educators. This is the best of Unacademy. Get the Plus subscription using the code NSS1 to get the best of Unacademy. Okay, get the subscription right away. So install this app before we go further. Install the Unacademy Learning app. Uh, this is how the learning app will look. It has nice two semicircular shapes, very symmetric about their self. Okay, and one more thing, we have a quiz show which is also happening today, which is the integer quiz show today. I have a new idea which I'm running through right now. So stay tuned. All right. So about me, a little about me. I'm N Srikant. I did my BTech from IIT Kharagpur. I have an AIR of 385. I've been guiding you guys for the last 4+ years, and you guys call me human calculator. Well, you'll know why. I'm a Sunrisers fan. It's been hard, but it's been good. Be a Sunrisers fan, and DC is equally marvelous, if not better. I'm a huge DC fan. Joker का big fan हूँ मैं. तो anything you want to say, put it in the comment section below, and I want all of you guys to like this video and share this video and subscribe to the channel. All right. So today we will be discussing about the chapter we are discussing today is magnetic effects of current. Okay, the current के कारण क्या magnetic effect होता है? We will be discussing that today. So this is a wonderful topic. It is very मतलब it's not visible to the human eye, and it also happened by accident. ठीक है. So we will discuss a lot about how this happened, what the effect of current is on the magnetic field, and how magnetic field is calculated using a current carrying body. All right. तो ये एक ओवरस्टेड का एक्सपेरिमेंट था. ठीक है. This all started with an experiment done by Oersted. It was not until 18th मतलब ये 19th century तक no one knew this. This happened only in the 19th century. Got it? In 1820, Oersted was explaining to his class or a group, मतलब accidentally एकदम he didn't even observe this, but then when the direction of current, मतलब he was passing current through a current carrying wire, and he also observed that there was a deflection in the magnetic compass. जब current ऐसे flow कर रहा है, he observed the deflection in the magnetic compass. It started deflecting left and right. All right. So this is what made him realize that current carrying conductors also have a magnetic effect on them. They produce magnetic effect. Current carrying wires produce magnetic effect. This is what he observed. Understood? So this is the one very important thing he observed, that by accident. And then he also observed this certain things, like when the direction of current in the conductor is reversed, then the deflection in the magnetic lead is also reversed. Okay, मतलब when current ulta hote hi, the direction the needle deflection also reversed. So this means from this he observed that it is a vector quantity, like it will also depend on the direction of current. So it will depend on direction of current. So that's one thing he observed. And one more thing, on increasing the conductor's current, he observed that it bringing the needle closer. Observe that on increasing the current in the conductor, like just like जो wire में current जा रहा है, if the current is increased, or if the needle is brought closer to a particular point, or if the needle is brought closer to a conductor, if this is brought closer to a conductor needle, if it brought it closer, or if the current increased, the deflection in the magnetic needle increased. So these are certain logical understanding that he Oersted has observed and given in terms of his observations. All right. ठीक है. So this was purely accidental, and एक बार accident होने के बाद he observed all these things, that the needle deflection depended on these two things. The needle deflection depended on the current and distance of separation. So these two things were what he clearly observed. Now, before we go further, we'll discuss more about what magnetic field is. मतलब ये magnetic field is a very new concept. So deflection in the magnetic compass implies that there is a magnetic field present. Field is मतलब ये magnets को deflect करता है. Magnetic field is given by magnets. All of you know magnets. You also have magnets everywhere. Like this is the magnet here. Everything, anything which sticks to a fridge, all those wall mounts, fridge mounts, all of them will have magnets behind. It's very commonly found. Radios में मिलता है. सब जगह magnet use होता है. ठीक है. So main concept before current was magnetic field. Magnetic field का जो magnetic field था, that was only related to magnets in the beginning. Understood? It initially was thought that magnetic fields were produced by magnets and electric field was produced by charges. The electric fields were produced by charges and magnetic field was produced by magnets. They never thought they both were linked together. So electromagnetism is a fairly recent concept. Understood? So electromagnetism means the link between electricity and magnetism, which didn't happen till 1820s. Only when Oersted observed this, then they started observing magnetic field also. So since we didn't discuss about magnetic field, I want to talk a little about magnetic field before we go any further. All right, I want to talk a little about magnetic fields. So इसके लिए सीधा एक concept ले लिया. Force on a charge due to a current carrying wire is the main thing. तो मान लो एक ऐसे current flow कर रहा है यहाँ पे. There is a current charge. There is current carrying wire like this, and a charge is placed at rest close to the current carrying wire. Then what it observed was there is no force acting on the body क्योंकि wire neutral है. Wire में जब positive charge भी है, negative charge. There are both charges in a wire. Getting it? Electrons will flow through the wire opposite to the direction of current. Both are true. The electrons ऐसे flow हो रहा है इसमें. But the total charge of a wire is neutral. Getting it? The total charge inside a wire will always be neutral. Electrons will be coming from somewhere else and going along in this path. It's like a railway train track. Electrons will be passing through the track type. Okay. So the total charge on this is neutral. So if you place a charge Q at rest close to this, it will not experience any force. Okay. But then if you start moving the charge, मतलब मान लो if you start moving it up or down or something. All right. So if this charge is moving forward, it will not go in a straight line. It will start experiencing deviations. It will start experiencing deviation. मतलब अगर ये deviation हो रहा है, मतलब it means there is some external force acting on a moving charge which does not act on stable charge, which does not act on a stationary charge. So this is where the whole thing came into picture. Like this is the main concept I want you guys to understand. Hi sir, aim ఎప్పుడు స్టార్ట్ చేస్తారు? EMI ఎప్పుడు స్టార్ట్ చేస్తారు అంటే we will do slowly on the go. इसके बाद we will do EMI. Okay. So today I am discussing, today's topic is the magnetic effect of current carrying wires. Understood? So इसके बाद eventually we will దీని తర్వాత we will get to that also. All right, Charit Krishna, hello by the way, welcome to this channel, and definitely hit the like and share button for this video and subscribe to the channel below. So before we go further, I want you guys to understand this is the main difference between electric field and magnetic field. When a current carrying wire will not apply a force on a charge which is at rest. Getting it? It will only apply force on a charge which has momentum. It is only apply. So this force will only act body having momentum, on charge having momentum, basically having. So this this deviation will be observed only on a charge which is moving. It won't be observed on a charge which is at rest. And one more thing, this current which is flowing is a neutral body. It is not electrically charged such that it will experience an electrostatic force. So the electrical force is absent, but there is some other force present. But there is another force present, another force which will be caused due to momentum of charges. Getting it? So this extra force which is caused due to momentum is only called as magnetic force. Understood? The magnetic force will be caused due to the presence of magnetic field. Matlab, just like electric force was caused due to electric field, magnetic force will be caused due to magnetic fields. All right. So this is about magnetic field. This is all I want you guys to understand. इससे मतलब if you understand this thing, it will become very easy for you to imagine or analyze this क्योंकि ये दिखता नहीं, you cannot see this outside, so most of you guys will find it tough to visualize it, but then if you can understand this particular example, it will be very easy to understand the whole thing. All right, so this is magnetic field, guys. The magnetic field is the field which produces magnetic force. This magnetic force is caused due to moving charge, is experienced by a moving charge and not by a charge at rest. So it will also depend on momentum of the body. One thing you have to understand. So that's the main crux. So the first law we will discuss about in magnetic field is Biot-Savart's law. The first thing we are going to be discussing today is Biot-Savart's law. Bio-Savart. ये सब मतलब they are not Indian, so it's not Biot-Savart, it's Bio-Savart's law. All right, so this is basically experimental. ये एक law है, तो it was experimentally observed. So laws generally, very few laws have been derived like Ohm's law. You can derive Ohm's law, but very few laws in general like gravitational law, electrostatic, law of gravitation, law of electrostatic attraction or repulsion. All these are observations. So Biot-Savart's law is observed experimentally. एकदम experiments किए. Biot and Savart, these guys have done experiments along in the 19th century. बहुत पुराने experiments. They have and observed experimentally a few things, which actually Overstood also said. We will be discussing the same thing. It said that magnetic field, we are observing magnetic field. It observed that the presence of magnetic field, presence of magnetic field due to current carrying wires, due to current carrying wire. So this was what they majorly experimented on, the presence of magnetic field due to a current carrying wire. Understood? Just give me one moment. You'll get better handwriting now. It has been observed experimentally that the presence of magnetic field due to a current carrying wire. Let's take the magnetic field to be B. This is generally represented by B. Okay, magnetic field is generally represented by B. So it was observed that B will be proportional to the amount of current flowing through the wire, and it is also understood that it is proportional to 1 by square of the distance between the two between the current carrying wire and the particular point. So magnetic field B, let me write the whole thing, rephrase this thing very neatly. The magnetic field B at a point is proportional to current flowing through the wire, and it is also proportional to 1 by r square, where r is the separation between wire and point. Clear? ऑब्वियस ना, ये वायर और पॉइंट के बीच का डिफरेंस ही होगा. इफ इट इज मोर द फील्ड वाज ऑब्जर्व टू बी लेस, एंड इफ दिस इज लेस द फील्ड वाज ऑब्जर्व टू बी वेरी वेरी हाई. मतलब स्क्वायर, इनवर्स स्क्वायर लॉ है. दिस इज आल्सो जस्ट लाइक ग्रेविटेशन और इलेक्ट्रोस्टैटिक फोर्सेस, इट इज इनवर्सली प्रोपोर्शनल टू स्क्वायर ऑफ इट. ऑलराइट, तो ये दोनों को इट वाज ऑब्जर्व्ड एक्सपेरिमेंटली. तो इससे before we go further, this has been observed only for biot and savart, observed only this for a particular small element of current, element of current flow. मतलब एक वायर अगर ऐसा चल रहा है, there is a current flowing through the wire like this, you only take a small element of dl length and current flowing through that is dl. So it was observed that small element of current flow, this b was proportional to I into dl also. मतलब it was proportional to length, it was proportional to I. So obvious, no, more length means more field was observed, less length means less field was observed. और current भी है, current more, less current less, and distance inversely proportional to square of it. So using all of this, we came up with a formula saying B will be equal to mu naught. So B will be proportional to the whole thing. So the proportionality constant was taken as mu naught by 4 pi. Why this came, we will tell you. I will tell you as you go. I into dl cross r by r cube. तो इसको इसमें सिंपल. और वन मोर थिंग, दिस पॉइंट में अगर ये करंट का डायरेक्शन ऐसा है और ये एंगल ऐसा है, तो इट वाज आल्सो फाउंड आउट दैट द फील्ड वाज प्रोपोर्शनल टू sin थीटा आल्सो. काफी सारे रिलेशंस है. we understood, when end up getting the value is IDL by sin theta by 4 pi r. This is the field due to, this is the magnetic field due to small element, due to small dl current carrying element. तो ये एलिमेंट क्या है, थोड़ा एक बार वी विल डिस्कस दिस एलिमेंट हियर. करंट एलिमेंट, व्हाट इज करंट एलिमेंट? A very small element dB AB of length dl of a thin conductor carrying current I is called as current element. The current element is a vector quantity, those whose magnitude is equal to the product of current and length of the small element having the direction of the flow of current. So why I want you guys to understand this is, we know one thing, I is scalar, right? We know current is scalar quantity. तो पर यहाँ पे डायरेक्शन कैसे लाते हैं? सो द मेन कॉन्सेप्ट हियर इज दिस स्मॉल डीएल एलिमेंट विच इज कैरिंग करंट. मान लो ये पूरा एक लेंथ है, स्मॉल एलिमेंट डीएल कैरिंग करंट, दिस विल हैव अ स्पेसिफिक डायरेक्शन. इफ यू ऑब्जर्व द डायरेक्शन ऑफ दिस इज वेरी क्लियर, इट्स वेरी स्ट्रेट. तो मतलब करंट अगर ऐसा है तो डायरेक्शन ऑफ डीएल विल बी इन दिस पर्टिकुलर डायरेक्शन. दिस इज वेरी क्लियर. बट यू कैनॉट, सिंस वी नो करंट इज स्केलर, we are going to use this. Since we know current is scalar, we use direction of dl as direction of vector current element. Direction of dl as direction of current element. Clear? क्योंकि we know magnetic field is a vector. Magnetic field is a vector. But then when you take current as scalar, it will not add up, because you know only position vector is there, but there is nothing else which gives a direction of current. And if you want to get a resultant as a vector, you have to be having vectors in this. So that is why we take dl element as the direction of the current element. Understood? तो ये dl element ये जो है, इसके कारण the field at db. So now we can define db will be equal to mu naught by 4 pi into I into dl into sin theta by r square. This is what was calculated experimentally. ये mu naught by 4 pi का value we will learn as we go forward. I hope this is clear. IDL is the vector. DL here is getting it. So इसका एक और method भी है. The another formula which is given for this is mu naught by 4 pi into I into dl cross r by r क्यूब हो जाएगा, क्योंकि ये r वेक्टर जो है the magnitude of it will be r. If you want the magnitude to remain same, you have to multiply another r at the bottom. You can also write it as r cap by r square. This, my friend, is the Biot-Savart's law. Tongue is not twisting. Biot-Savart's law. Savart's law. Biot-Savart's law. Okay, so its value is given by mu naught by 4 pi into I dl sin theta by r square. In vector form, it is mu naught by 4 pi into I dl cross r by r square. Understood. So this is what it observed. With the help of experimental results, Biot and Savart arrived at a mathematical expression that gives the magnetic field at some point in space in terms of current that produces the field. So current carrying wire which producing the field, that current will produce the field, which is given by this formula. That experiment is based on the following experimental observations. Magnetic field dB at a point P associated with length dl element of a wire carrying current. A steady current I. So dB will be proportional to I, dB will be proportional to dl, dB is proportional to sine theta, and it is proportional to 1 by r square. So using the whole thing, we will get dB is proportional to I dl sine theta by r square. Guys, if you ask me, this itself is more than enough to solve any problem. Mu naught by 4 pi जो constant है वो constant हमेशा रहेगा. So imagine a magnetic field to be in this format. More length, more field. More angle, more field. And at 90 degrees it will have more field. And more current, more field, and more distance, less field. This logic will be very important for you to solve any problem. Not just one or two, but any problem you want to solve in this. This logic you have to apply. The equivalent concept, the equivalent value is mu naught by 4 pi. So in vector form अगर देखा जाए, so one thing we know, whenever you get sin theta, okay, sin theta का meaning यही है कि it is having some cross product. And one more thing we observed here, one more observation it was observed is that the direction of field was perpendicular to plane of r vector and dl vector. It was observed that the direction of field was perpendicular to both r vector and dl vector. So in दोनों को मिला के we are getting a very nice vector form, which is, so obviously, you know, the vector, if the magnetic field is perpendicular to the plane of current and radius vector, we know it is having cross product relation. And the moment you see sin theta relation, you can directly say dB vector will be equal to mu naught by 4 pi into I into dl cross r vector by r cube. This is one way of writing it. Understood? So this is only the Biot-Savart's law in vector form. Otherwise, you can also always use, we'll discuss a lot about the direction today. You can always use the magnitude form. इसका हमेशा magnitude form use कर लो, आराम से हो जाएगा. Because I know cross product calculation काफी मुश्किल है ना generally. So any such problem you have, you can directly write off this I dl into sine theta by r square n cap, where n cap is perpendicular to r vector and l vector. Got it? So this is Biot-Savart's law in multiple fashion. आज हम खूब problems करेंगे. We will do lots of problems today and tomorrow also. So definitely stay tuned. Hello, good evening, Siddheshwar. Yes, I will try to cover those. Charit Krishna, I will cover due to infinite wire and semi-finite wires today only. All right. So the units of magnetic field which we discussed before is Tesla. All right. The unit of magnitude magnetic field is defined by Tesla. Tesla is also given by Weber per meter square. It is given by Weber per meter square, also as Newton per ampere meter. One Tesla is also given by Weber per meter square. ये Weber क्या होता है? This is a new term which you never heard. This is the unit of magnetic flux. Getting it? This is the unit of magnetic flux. Weber is a unit of magnetic flux. We will be discussing about this eventually when we talk about flux and EMI के topic जब आएगा, that time we will definitely look much more into the unit of magnetic flux, which is Weber. But otherwise, it is Tesla is Weber per meter square. Generally, you know how flux is defined, no? whatever field into area. Same thing will apply here. Field into area, magnetic field into area will be given by Weber, will be flux, and similarly flux by meter square will give me Tesla. Understood? So it is also defined as Newton per ampere meter, and so a non-SI commodity generally used is Gauss. Gauss is also used, but Tesla is also used. 1 Tesla is 10 power 4 Gauss. Generally बहुत कम होता है. The magnetic field intensity is very less in general. So we use Gauss because it is very less, more related to normal values. Tesla generally is very high, so anything you want to find in Tesla, it will be very huge. The generic values you will get in terms of 10 power minus 6 Tesla, 10 power minus 7 Tesla. So it's सब कुछ 10 power minus 5 Tesla. So instead of all these, we will start using Gauss. Getting it? So each this Gauss will become 0.1 G. 0.1 G, 10 power minus 2 G. Those are also decently strong magnetic fields, and that is what we will be getting. So the magnetic permeability of free space. This is what is something we discussed. So mu naught जो भी है, the value of this is 4 pi into 10 to the power minus 7, or you can also say mu naught by 4 pi will be equal to 10 to the power minus 7. तो ये theoretical value है इसका. It has been calculated, observed experimentally. Again, this is experimentally observed. Experimentally observed value of mu naught by 4 pi. Now, अब इसमें mu naught का value, how will it be? Okay. So we'll just find out magnetic field का क्या unit था, Newton per ampere meter ना. Magnetic field will have a unit of Newton per ampere meter. This will be equal to mu naught into length into, so इसका dimensions एक बार देख लेते हैं. तो आजकल तुम लोग dimensions, मतलब I'm pretty sure most of you are already good at dimensions, but then I will derive it in some ways which I know. मतलब देख, dimensions derive करने के लिए there's nothing, you need not remember everything which is happening to know dimensions. You just need to know a few things. Like जैसे कि हम मैग्नेटिक फील्ड का जो हम देखें, इसका यूनिट है, लेट्स गो टू प्रीवियस पेज, इट इज न्यूटन पर एम्पियर मीटर. तो इससे हम आई थिंक वी कैन गेट अ लॉट ऑफ थीम फ्रॉम दिस. न्यूटन पर एम्पियर मीटर, तो न्यूटन का क्या डायमेंशनली केजी मीटर पर सेकंड स्क्वायर डिवाइडेड बाय एम्पियर का आई है और मीटर का एल है. तो इसका क्या आ गया, m इंटू टी पावर माइनस 2 इंटू आई पावर माइनस 1 हो गया डायमेंशनल फॉर्मूला फॉर फील्ड. Now this is equal to mu naught into dl into r, no, mu naught into dl cross r by r cube, or you can also say mu naught into I into dl sin theta by r cube, r square, sorry. So इसमें we know everything else also. Dimensions of the whole thing will be mu naught का dimensions into current का dimension into m by m square. तो मतलब ये m power m मतलब ये length है, length power 1 by length power 2 will become m. तो इससे क्या आ जाएगा, the dimensional formula of mu naught will be equal to m into l power 1 into I power minus 2 into t power minus 2. This is the dimensional formula for this. Got it? So dimensional formula के लिए any one you know with relation between magnetic field and anything else, you can just use it to find the dimensions. ये dimension का top quality question है, तो if you definitely like this, hit the like button there. Mu naught value is 4 pi into 10 to the power minus 11, so minus 7. So now you can also call it as Newton per ampere square. You know m, so you know one thing, right? So this one, so this is the magic of dimensions basically. So this one I can also write it as m l power 1 t power minus 2 by I square. So this can also be simply written as Newton per ampere square. So this is the magic of having dimensional formulas. So this is the SI unit of it. Mu naught will be equal to 4 pi into 10 to the power minus 7 Newton per ampere square. So this is about permeability. This is magnetic permeability in free space and air. So this is very similar to, एक और thing I'll tell you. This is, we will discuss about this later, but this is very similar to permeability in free space, like very similar to epsilon naught. Okay. So for matter you will have different epsilon naughts. Epsilon naught into epsilon will be equal to epsilon naught into epsilon r. No? Similarly, here also you will get mu will be equal to mu naught into mu r. This will be relative permeability. This will be relative permeability, and this is absolute permeability in free space. Absolute permeability in free space. So iska value we know already, and otherwise this will also be used in a lot of cases. We will be discussing that as we go forward. All right. So this is all you need to know about mu naught. So generally, one more thing which is very useful to do it is leave any equation in terms of mu naught by 4 pi only. Leave it like this, because kabhi kabhi mu naught will get cancelled. Kabhi kabhi 4 pi will keep getting cancelled. So to make it simpler calculations, it's better to leave it in mu naught by 4 pi when you're solving this problem. So अभी तक हम क्या पढ़े? So this is a gist about what we did till now in the first half an hour. So the point is dB is mu naught by 4 pi into I dl vector cross r vector by r cube. This is the magnetic field due to a current element. Due to a current element, मतलब ये element के कारण magnetic field है. So if you want to calculate for the entire wire, ये dl जब भी दिखेगा, whenever you see dl, you know there is integration involved. For entire wires and all, we use integration. Simple. Use integration. We are going to use integration today, so it's pretty logical. So one more thing, it's observed the direction of magnetic field is always perpendicular to the plane of ideal and r vector, where ideal and r is the plane of wire, plane of ideal, and r is the plane of the wire. So ideal, whatever direction current is going, ideal, that is the plane of the wire, along with the direction of the point. R vector and ideal vector together form a plane. So मतलब मान लो करंट ऐसा फ्लो हो रहा है, एक वायर ले लिए, current is flowing in this wire like this, and the point is right in front of you. This thing is the plane of the wire. So that is about the plane of the wire. Next, magnetic field on the axis current carrying wire is always zero. मतलब ये we will derive this also. Magnetic field on the axis of a current carrying wire will be zero. The magnetic field on the perimeter of a circular loop is always minimum. ये हम derive करेंगे चलते चलते. All right. So this is the first part of the section where we discussed a little theory. So if you want to crack IIT-JEE, this is the best place to be at, especially at this time of the year, this time of the century, or this time of human life. Okay, this stage of human life is where you need to crack IIT-JEE using India's largest online learning platform. मतलब जहाँ पे offline classes नहीं है, and everyone is getting tormented by corona across the world, not just our country or state. So you have to sit at home and stay safe and crack IIT-JEE with India's largest platform, which is what currently India's largest platform is, Unacademy. Okay, get plus subscription and access unlimited live and recorded courses from India's best educators. All right, get the subscription using the code NSS1. If you can use this code NSS1, you will get an extra offers also on this plus subscription. So what do you get with plus subscription? Plus subscription will give you access to the best of Unacademy. Will give you access to the best of Unacademy. Now, what is the best of Unacademy? It has daily live classes where you can chat with your educators, engage in discussion, ask live doubts, and answer polls all while the class is going on. Everything when the class is going on only you can, like here I know there's a little delay in what is happening between there's a delay between the chat and the class, but there you have direct live session where you will have no delay. Everything will while the class is going on, and you have wonderful polls. So one of the such examples of polls is the integer quiz show episode 1, which I'm starting today. So do stay tuned in, guys. In IQS, search for N Srikant on the Unacademy app and in subscribe to me right away, where you will get unlimited quizzes. And I've been conducting quizzes for a very long time now on the app. So do stay tuned. There's a lot of fun happening. All right. So you get live tests and quizzes also, which with which you can evaluate your preparation with regular mock test quizzes and get detailed analysis on your performance. You get detailed analysis on your performance. Not only that, you'll have structured course. All the courses are structured in line with your exam syllabus to help you prepare for it. Like everything which you want in a preparation. Like for JEE, you need every syllabus for entire syllabus for IIT-JEE. You will find it inside. If you want to prepare for NEET, everything in NEET you will find it here. So you will have it in a structured way. Hello Aditya, how are you? Long time. So everything you'll find it in a structured way. You will have unlimited access to all the live and recorded sessions to watch at the comfort of your home. So any such recorded session, if you miss a class, outside classes, you cannot come back and work on it. But here you will get unlimited access to all courses whenever you want. You can just watch. Yes, I'm coming to the app, man. Today we have the quiz show today. Definitely, today I'm starting a new quiz show at 10:30 p.m. As usual. I will be there every day across the entire holidays. All right, definitely I will see you there. So yes. So the cost of the subscription is 38,500 for 1 year. Like you might feel this is different, but let me tell you one thing. What Joker says in the movie Dark Knight: when you're good at something, never do it for free. So Unacademy have been so good and revolutionary in this, so that is why they've charged a nominal fee of 38,500, which after using the code NSS1 will come to under 35k. It is 34,600. So you will also get six months ka subscription for 28k, and if you use the code NSS1, you get it for 25.2k. So this is the code word NSS1. All right. One more thing, it might look little big, but then if you break it down, it will become much more simple. It costs around 2,888 rupees per month for physics, chemistry, and maths. So if you break it down to daily classes, it will come out to 32 rupees per day on physics, 32 rupees on chemistry, and 32 rupees in maths. तो मतलब 32 रुपीज में आजकल तुझे क्या मिलता है? ये कोक बॉटल जो मैं पी रहा हूँ ये भी 32 से ज्यादा है, 600 ml. So you ask me, it is worth it. So use the code NSS1. It's pretty cool. You get the best of Unacademy. You get a lot of wonderful sessions. All right. So if you are cracking IIT-JEE in 2022, you can use this code and the cost is 56k. After using the code, it will become 50,400. This comes out to 2,100 rupees per month on physics, chemistry, and mathematics. So if you break it down further, this will come out to 23 rupees per day on physics, chemistry, and math. 23 rupees, man. That's all. This is like a 200 ml Coke bottle, a 5-star chocolate. 23 rupees. So if you are preparing for JEE on a regular basis, which you should be doing if you want to aim for JEE, you can go for this because it is going to be so good economically also in the long run. All right. Not only that, they have also introduced the iconic subscription where you will be given an extra personal coach, which is especially helpful during this time of Corona, where you don't have any teacher to guide you through it. I know a lot of students who wanted to take my help, who wanted me to help them. I've helped a lot of students in class and out of class also. A lot of them have been struggling. So if you want to have that personal interaction with a teacher whom you really want to guide you through, Unacademy is providing you exactly that. He's providing you one expert expert guidance expert from anything, especially for IIT-JEE, to help you with your preparation strategy. You will be given detailed test analysis and you will also be given study plan. The personal coach will analyze your test analysis and give you a proper study plan based on which you can crack IIT-JEE sitting at your home in a more composed manner, despite instead of getting confused. What should I read? I don't know what to apply. A lot of you have this panic, right? I don't know what to study now because you have too many things to study. Of course, I get it. There are too many things to study in physics, chemistry, and math, 3 subjects that. But you need someone to help you with how to plan. Like you get stuck, most of you get stuck with single chapter for a month. If you sit with one EMI topic for 1 month, you're gone. It's very tough. You will not be able to solve the other problems. So personal coach will be there exactly for you to help you in that kind of scenarios, where he will give you a bi-weekly and weekly plans with review so that you can see how you are progressing. Not only that, you also get all the benefits of Unacademy Plus also. The cost of this will be little more because you have an extra educator. The cost is 56,000 for 1 year. Use the code NSS1 to get it for 50,400 only, 10% off extra. You're saving 6,000 in between here. This is coming out to 46 rupees per day on physics, chemistry, and maths with a mentor. And for 24 months, those who are cracking 2022 JEE, I know this, especially in this Corona time, I think it's going to stay easily till 2022. This is a very long process, and the second wave is yet to come. We don't know how long it will take for the vaccines to actually take place in India. So those who want to crack 2022 JEE also, you can use this code NSS1 to get this iconic subscription. The cost is 86,000, but if you use the code, it will come down to 77,400. This might be coming out to 32 rupees per day. So awesome sauce deals are here. Go for it. Don't forget to use the code NSS1. Yes. So now we will discuss about the direction of magnetic field using the right hand rule. Okay. The right hand screw rule, we will be discussing about right hand curl method and the right hand rule. So suppose there is a करंट कैरिंग सेम एक ही सेम फॉर्मूला को एक dl वेक्टर ऐसा है. The dl vector is a straight line like this, and r vector from here is like this. And this is r vector, and current is flowing this way, so the direction of current is like this. So this is the angle theta. So what will the magnetic field be? dB will be equal to mu naught by 4 pi into I dl sin theta by r square. In vector form, you will write I into dl cross r vector. dl vector cross r vector by r square into mu naught by 4. Got it? So either one of these both you will keep using. So now you know the how to find the direction of right hand, direction of cross product, right? You take the first vector's direction, which is this direction, and you swipe your hand along the direction of the second vector. dl vector cross r vector means you swipe your hand from dl towards r direction like this. So if you are actually pressing it like this, just give me one moment, I need to see. अच्छा ऐसा है. Okay, so the direction of dl vector is like this, right? And the direction of r vector is like this. So you do dl cross r. ये dl cross r कर दिए तुम. So what is the direction of direction you're getting? You're getting the direction is inward towards you. अच्छा ये राइट हैंड से करना है, लेफ्ट हैंड रूल. तुम्हारा राइट हैंड मेरा लेफ्ट हैंड है ना, तो ये राइट हैंड है मेरा. इफ यू ऑब्जर्व, दिस इज हाउ माय राइट हैंड विल लुक. तो अब देख, dl ऐसा है, r वेक्टर ऐसा है, तो मतलब dl cross r is coming towards inward. So that is what you will get for the direction of r vector. तो ये सब confusion है ना थोड़ा, मतलब dl cross r में भी थोड़ा confusion हो जाता है. So the best way to do it is using the right hand curl method. तो right hand curl method is, this is a revolutionary method, मतलब एकदम simple method है. इससे you can calculate any direction of magnetic field. What you will do is, wherever the direction of current is flowing, you put your thumbs up, put your thumbs up and roll your close your hands this way, such that the direction of current is shown by the thumb. The direction of current is shown by thumb. Understood? So right hand curl method states that whatever direction of the hand curl is happening, मतलब curl को क्या बोलते हैं? ये सब curl बोलते हैं. This is curling. This is curling. This is not, this is opening up. This is curling, right? This is curling in. This is opening up. So when you put your thumb in the direction of current, whichever direction your hand is curling, that is the direction of current. Thumb along current carrying wire. The curl of hand gives direction of curl of right hand. ये right hand rule है, left hand से मत confuse करना. It is the right hand rule. So curl of right hand gives direction of magnetic field. Due to current carrying. This is it, guys. I hope it's clear to you guys. you just put your thumb in the direction of current. बस जो direction में ये fingers move हो रहे हैं, that is only the direction of magnetic field. ठीक है. अब ये थोड़ा example से let's figure out. One more thing before you go out, you have to generally take the direction. If it is going inside, which is going inside like this, direction inside will be represented by cross. मतलब inside ऐसे भी सोचो. Direction inside है तो मतलब it will be taken as cross, and if the direction is outward, it is taken as dot. This is one very important thing. All right. तो अब इसमें देखते हैं what is the direction of magnetic field in this. अब यहाँ पे current carrying direction इस side है, तो what is the direction of magnetic field at A? First we'll see at A. So if you see, thumb direction में कर दिए, thumb is in the direction of current. I am putting my thumb like this, and I'm trying to put my hands. I'm trying to see where the fingers are pointing. You guys can check where the fingers are pointing. If you observe that fingers will be pointing, fingers point inside. That's all, no? So the direction of current is upward. The fingers are pointing inward, like into the page. If fingers are pointing into the page. Getting it? So from this you will get the direction of this will be x. And similarly here it will be exactly opposite. It will be coming outward. Fingers point outside. So the direction of field will be. Okay. And one more thing we observe, if the direction of current is reversed, एकदम जो है hand उल्टा हो जाएगा as seen here. If the direction of current is reversed, if the direction of the current is reversed, the direction of magnetic field also reverses. Field also. Very important point. So current and magnetic field are thus very closely related and are very friendly with each other. ठीक है. तो यहाँ पे क्या होगा? I won't even solve this problem. At E the value will be outwards and at F the value will be inwards. Clear? तो इसमें भी देख, current is X मतलब the current is going inside. Current is going inside. So what is the field at C? The value of field at C will be downwards. If you observe, the value of field at B will be downwards. Similarly, it's going inside. Direction of current is inside like this, and the direction of fingers is pointing upwards. So यहाँ पे direction कैसा होगा? It will be upwards. This. So exactly अगर उल्टा हो गया, if you just flip the whole direction of current, here it will become up and here it will become down. I hope you understood ki how direction of current will impact, and if you know one direction, you can solve all directions using the same of right hand thumb rule or right hand curl method. Right hand curl method. So this is it for direction of magnetic field. So one more thing. So another way is circular current. Suppose circular current is flowing. तब क्या करोगे? So direction of current everywhere. If you observe a loop, if you observe a closed loop, everywhere direction is going at a particular point, the direction will remain same. Like if you see inside the sphere, inside the circle, everywhere you put your thumb in any particular direction you put thumb, the direction of a field is always same. Direction of field in the middle due to all elements will be same. So you can directly add of them scalar wise and you can give the total direction to be this. Similarly, if the current is flowing in this direction, so right hand curl method, you can use the inverse of it also. When current is flowing in circle, you take current circle to be like this and the direction of magnetic field will be given by thumb. So circular current, exactly, curling fingers will give direction of current and a thumb will give you field line pattern. Understood? So you can always say this is the inverse of the previous method. Current carrying side तुम thumb लगाओगे तो hand will give direction of field. In this case, you are curling your hand in the direction of field, direction of current. Thumb will give you field. So this is exactly inverse of the previous one, but then you can just say logically everywhere you just curl your right hand. If only single current field is there, you just put your thumb along direction of current and then curl your hand, direction will give field. And if there's a loopy current, you curl your hand in the direction of loop, the thumb will give you current, gives field pattern. Understood? So isme, if you observe, this is coming outside. This particular case in B, it is going inside. Similarly, if your current is flowing in this particular anti-clockwise direction, this is the anti-clockwise direction. It is towards the outer observer, or it is also called outwards, or also called K cap in most of the cases. And if it is clockwise, it is inward, which implies it is minus K. All right, so this is all about direction of a magnetic field. अब डायरेक्शन के बारे में सब कुछ जान लिए हम. So now we will discuss about magnetic field surrounding a thin current carrying wire. अभी तक we discussed about element, right? एक element मतलब एक छोटा सा part है. Element is a very small part of a current conductor because a wire is generally very long, very long. Current element means a very small length value. So a very small element का value अगर हमें पता है, we can just add the entire thing, we can integrate the entire thing across the long wire to get total field due to a current carrying wire. ये formula बहुत useful होगा because you will be using this in a lot of places, so it's better to remember a few formulas, maybe a few formulas. All right. So here we go. Let's take current carrying wire. Current is traveling from B to A along this particular direction. Got it. At point P, whose perpendicular distance AB from OP is A. Perpendicular distance is given by OP. But remember, whenever you have cross product involved, perpendicular distance will be reused. Like torque R cross F. You will simply write R perpendicular into F. Similarly, here it is DL cross R. I into DL cross R by R cube. No? This is what we got. So I can also write this as mu naught by 4 pi into I dl into R perpendicular by R cube. You can also write it this way. Ray optics. Let's see. No one asked me for ray optics, so but ray optics is a very big topic. Let's see, man. Let's see how long this goes. We will definitely cover nuclear physics. I'm planning to cover nuclear physics also along with this. I will definitely keep you posted about what will be what once in the coming days. All right. I will be teaching ray optic. I will be teaching magnetic effects of current as well as nuclear physics. So we will see after these both we can start ray optics. Okay. So the field in this particular question, mu naught by 4 pi into I dl into R perpendicular. You always write this. Okay. This is not just generally for only torque. You can always see this as a very nice option. लिख सकते हैं आराम से. A is the perpendicular distance. All right. So so now let's start solving this. Let's start solving this problem. मतलब इससे नहीं, we will have it using sin thetas and sin thetas. ऑलराइट. तो यहाँ पे एक करंट एलिमेंट के कारण फील्ड कितना है? करंट एलिमेंट के कारण फील्ड इतना ही है. I'll write it in much more simple method because now it will be easier to solve it. So the dB current will be defined as mu naught by 4 pi, which is always there, into I into dl by R square to angle theta. This particular instant you take angle theta. This is R, this is ideal vector. So the angle between them will be, if you take this is 180 minus alpha. So this angle is theta. This angle will be 90 plus theta. All right. So we know ideal dl by R square into sine 90 plus theta. What we do. But what is the value of 90 plus theta? 90 sin 90 plus theta is also equal to sin theta, sin 90 minus theta, which is cos theta, right? तो इसका वैल्यू कितना आ जाएगा? तो आइडियल ये सब अब डिराइव करेंगे. R can be written as A into tan r, हाँ r is not a tan theta, r is a secant theta. इसको ऐसे करके एक लिख सकते हैं द r वेक्टर. एंड dl वेक्टर इन टर्म्स ऑफ थीटा अगर लिखना है तो dl को कैसे लिखोगे? length is length, right? Length is r into sin theta. So dl will be equal to r into तो dl का वैल्यू कितना लिखोगे? तो बस dl को लिख छोड़ ही सकते हो ऐसे. We can leave dl like this only. Since we know the angle is theta here, sin 90 plus theta, we can leave them like this. L is r sin theta. तो इसमें क्या होगा? आएगा u naught I by 4 pi into dl by a secant square theta into cos theta. I hope this is clear to you guys. mu naught I by 4 pi into dl by a secant square a square secant square theta into cos theta. तो dl को क्या लिखोगे? Now what is the relation between dl and the whole thing? So dl is given like this, right? तो जब l ये d थीटा मान लो, ये dl होगा और ये l है. So what do we know about d relation between l and r? So we know l is r sin theta, right? You can also write L as a tan theta. इसको ऐसे भी लिख सकते हैं. L is written as a tan theta. So you can write dl by d theta will be equal to a secant square theta. तो इससे क्या आ जाएगा हमें dl का वैल्यू? dl value will be equal to a secant square theta d theta. This is a very important derivation. You can use this here. dl को क्या लिखोगे? dl को a secant square theta d theta लिखोगे. So this whole thing will now become applying to. This whole thing will become u naught by 4 pi u naught I by 4 pi into dl को a secant square theta a secant square theta by a square secant square theta into cos theta d theta हो गया. Wonderful solution here. Can you understand this? Hello. Yeah, congrats man, by the way. Yes, nuclear physics also I am planning to start simultaneously with this. Though we will have a break for 2 days and then I will start both of them. This I will continue along with that. Or I have a couple of strategies. And by the way, Ramesh, today we have the quiz, so do come to the quiz today. All right. Definitely don't miss the quiz, Ramesh. So it's going to be a lot of fun. So yes. So this is what we will get. इसको और simplify करोगे. So now let's simplify this. mu naught I by 4 pi ये हो गया into cos theta d theta हुआ. Now what is the integration of cos theta d theta? It is sin theta, right? It is sin theta, and you are taking this as reference point. You are taking the 0 point to be OP. The reference line is OP. So below that line angle will be negative. Below angle will be negative, and above the angle will be positive. No? So this is one standard frame. This is general analysis which we do. So mu naught I by 4 pi a into cos theta d theta is the value. और इसका sin, so इसका integration क्या होगा? mu naught I by 4 pi a into sin theta from minus theta 1 to from minus phi 2 to plus phi 1. Minus phi 2 to plus phi 1. तो इसका value क्या आया? mu naught I by 4 pi a into sin phi 1 minus sin minus phi 2 which will become plus sin phi 2. तो ये एक फॉर्मूला आपको याद रखने से it will become much easier for you to solve. Getting it? So this is how we derive it. एक simple सा derivation है. तो यहाँ पे हम dl का relation निकाले in terms of l and a. Basically a is what is given, no? So based on a we can write L is a tan theta, so dl will be equal to dl by d theta. I differentiated this and I found this. So this is a very nice technique. And one more thing, everywhere the direction of current is fixed and RE vector is changing. So what will happen to the direction of, so if you observe DL cross R, right? DL cross R. So if you observe everywhere, each and every each element will have same direction of field, because this is the plane of dl vector and r vector, and we know the magnetic field will be perpendicular to plane of dl and r. So you just use dl cross r hand curling method. The direction of thumb is this way and the direction of r vector is somewhere like this. So the direction of curl will be inwards, which means the direction is, or you can also write this. Main syllabus, has it reduced? It has reduced. I don't know the exact details of what all got reduced, so we'll just go with the flow. The moment we see something has been removed, we will not discuss that. All right. So this is a very important formula यार. याद रख लो इसको, mu naught I by 4 pi a into sin phi 1 plus sin phi 2, where phi 1 and phi 2 are above and below. Very important point. Phi 1 is above and phi 2 will be below, or vice versa. If they are on same side, you will get different answers. All right. So I hope this is clear. So okay, this is the derivation for it. एक छोटा सा क्वेश्चन है इसमें. Find the value of current of 2 amperes is flowing from A to B. Find the field due to the current carrying wire at point P. Even this angle is 30 degrees and this angle is 60 degrees. Take root 3 is equal to 1.73. All right. So I'm going to give you 1 minute. Just give me 1 minute. Put the timer. I'll put the timer. Uh, we will be good to go. Long time since we've done. Yes, your time starts now. Let's see. This question, exact question you didn't do because I made this question up. The values can be similar or different. Ramesh is doing everything. Very good, man. But I'm very happy with the way you are doing it. So tell the answer for this. Today we have integer question, Ramesh. Be prepared. All right, time's up. Great job, those who have finished it within time. But those who have not finished it, you need to be a little quicker today. Quicker, because this is an easy question. Okay. So solution will be what? सीधा formula substitute कर दो. Mu naught by 4 pi into I into dl into I. What is the formula we got? I by 4 pi a. I by a into sine theta 1 plus sine phi 2. So break it down into such compartments so that it will become easy to solve. This mu naught by 4 pi we know already, 10 power minus 7 into I by a is 2 by 10 into sine phi 1 plus sine phi 2 is sine 30 plus sine 60. If you observe this, how much is it? 0. This is 2 by 10, no? It's 2 into 10 to the power minus 8 into sine 30 is 0.5 plus sine 60 is 1.73 by 2, 0.865. Or we can just say 1.73 by 2. So take by 2 common everywhere, you will get 2 into 10 power minus 8 into 1 plus 1.73 by 2. 2 and 2 are gone, you're getting the value to be 2.73 to the power minus. यस वेरी गुड, दिस इज अ सॉल्यूशन। एकदम सिंपल सी बात है, कोई टेंशन नहीं है, आराम से हो जाएगा। द आंसर इज क्लियर। यस, ऑसम गाइस, ऑसम सॉस। ओके, नाउ दिस वन यू ऑब्जर्व। अब दिस इज अ वेरी थियोरेटिकल क्वेश्चन, इसको तुम देख के बताओ क्या, व्हाट इज द मैग्नेटिक फील्ड अलोंग द वायर एट पॉइंट पी। मैग्नेटिक फील्ड अलोंग द वायर, अब इस टाइप का सिचुएशन में क्या होगा। अब ये एंड का एंगल जो है वो एंगल 0 है, ये एंड का भी एंगल 0 है, बोथ phi1 will be equal to phi2 will be equal to 0. So then what will the magnetic field be? Mu naught I by 4 pi into A. A is a perpendicular distance, यहाँ पे perpendicular distance भी defined नहीं है, into sin 0 plus sin 0, which will give out to be 0, big 0. मतलब along that, so this is what we observed. One more thing, no, it was observed mathematically, experimentally also. Along the line, field is always 0. ये बहुत useful होगा, because when you calculate multiple fields this will become very complicated if you don't know this difference. Along the line of wire the field will always be 0. Very very important point. Along the direction मतलब यहाँ पे any point on this surface like P, Q, R, all of them will have magnetic fields 0. So very interesting observation this has been. All right. So next one thing, current I flows through a square frame of side A in counterclockwise direction. What is the magnetic? So this current carry the same. तो इसको एकदम ऐसे करके ड्रॉ कर देता हूँ. Frame having side A, right? Each frame at the center, each side is A and A and A. So what is the angle subtended by each side? By square we know the logic, right? That the angle subtended by each side across the other side will be 90 degrees. Angle subtended by each of them will be 90 degrees. So current is flowing in anti-clockwise direction. Matlab current I, let's take, is flowing in this particular direction. So what is the perpendicular distance? If you drop a perpendicular, ये पूरा A है, तो ये कितना होगा? Perpendicular, R perpendicular will be equal to A by 2 ना, क्योंकि यहाँ पे एक A by 2 है, ये ऊपर एक A by 2 है, दोनों मिलाने से टोटल A आएगा. Getting it? So R perpendicular will be equal to A by 2. All right. So and we know what are the two angles subjected, 45 degrees and 45 degrees. तो इसमें अप्लाई कर दो. The field due to one wire, due to wire 1 2. तो इसको 1 2 ऐसे नहीं लिखते हैं. We'll write each wire as 1. Wire is 1, this wire is 2, this wire will be 3, and this wire will be. So B due to wire 1 will be how much? Mu naught by 4 pi into A by 2 into I into sin 45 into 2. This is coming out to be mu naught I by 4 pi A into 2 times 2 sin 45. 2 sin 45 is root 2. So A due to 1, the direction, the field is mu naught I by 2, mu naught I by 4 pi A into 2 root 2. And what is the direction? If you observe, direction of field will be outwards. The direction will be outwards. So you just simply take the direction of thumb along the direction of current and find out what is the direction of thumb. Thumb is showing outward. And if you observe, everywhere thumb is showing outwards. Not only here, every side will have same direction. So from this we can also say, and magnitude of current is same, R perpendicular is same. So B due to 2 will be equal to B due to 3, will be equal to B due to 4, will be equal to B due to 1. Same current, same R perpendicular and same direction. These three are there. So from this directly you can write all of these together. So B total कितना होगा? 4 times B1 vector, which is 4 into 2 root 2 into mu naught I by 4 pi A. तो ये वैल्यू कितना हुआ? 8 root 2 mu naught I by 4 pi A. तो इसमें तुम बहुत सिंप्लिसिटी भी कर सकते हो. यू कैन ऑल्सो राइट इट लाइक 2√2 mu naught I by pi a. Simple. Some form like this. Clear? So this is it, guys. Kindly note this down. It's a very useful question. We will do more another kind of this problem only now. All right. So current flowing through an equilateral triangle frame of side B in clockwise direction. This is the next question. इसको थोड़ा lengthy कर लेते हैं because we have lot of space here. Equilateral triangle के कारण magnetic field कितना होगा? Everywhere you have to take the angle to be 60 degrees. I've tried so hard and got this far. In the end, the triangle matters. B. I'll call this B1, I'll call this B2 wire, I'll call this B3 wire. So the three wires are like this. Current is flowing in clockwise direction. इस बार current एकदम clockwise direction में चल रहा है. The magnitude of current field at the current frame with the center of the frame. मतलब center of the frame is geometric center. Center means geometric center, though it will be same in all cases because it's an equilateral triangle. और यहाँ पे एक एक का एंगल कितना होगा? You observe this angle will be equal to 120 degrees. एकदम ड्रॉप किए तो ये एंगल 60 degrees हो गया. It will be much more comfortable compared to a square because each side will have 60 degrees. Got it? So phi1 will be equal to 60 degrees and phi2 will be equal to minus 60 because this is the reference frame. And इसका एक बार triangle देखा जाए तो what is the length of that point? If you drop a perpendicular, this length is ये 60 degrees है, तो एक और भी कर सकते हैं. ये angle 30 degrees हो जाएगा. Let's forget about this. So you can take this height to be a. So we can say this length is b by 2. We can also say a will be b by 2 into tan 30. समझ में आया? So we can also say tan theta here. In this particular small triangle, we can say tan 30 degrees will be equal to a by b by 2, which is 2a by b. Substituting this, we will get a will be equal to b by 2√3. This is the next observation we have. We know the perpendicular distance. We know the value of phi1 and phi2. So we can find out field due to 1. Magnetic field due to 1 will be equal to mu naught into I by 4 pi a. By 4 pi into a. A is nothing but b times 2√3 into sine 60 plus sine 60. 2 times sine 60. So from this क्या आएगा? Mu naught I by 4 pi b into 2√3 into 2 times √3 by 2, which is 2√3 into 2 times √3 by 2. ये 2 cancel हुआ, so you're getting 6. This is coming out to mu naught I by 4 pi b into, this is field due to 1. Similarly, field due to 2 also will have same values. And what is the direction, by the way? The direction of current is this way, and the direction will be inwards. Here if you observe, the direction is inwards, which implies use cross. B2 also will have same value and direction also inwards. All right. So similarly, B3 also will have same thing because this wire 2, इसका भी same angles है ना. Everywhere it is symmetric. This angle is 60, this angle is 60, and this angle will also be a by 2. Similarly, here also this is 60, this is 60, this is a by 2, this is b by 2, and this is b by 2. Using the same logic, we will end up getting the value mu naught I by 4 pi b into 6 by symmetry. So now applying the whole thing, we will get b total will be equal to b1 vector plus b2 vector plus b3 vector. Remember one thing, superposition is not just adding vectors generally. So which is coming out to be mu naught I by 4 pi a into 18. Oh, that's a huge value. You get 9 mu naught I by pi a. So this now this is about the current the small wires. When you have a part of the wire, you can take this to be infinity. Now the magnetic field due to an infinite current carrying wire. मतलब ये wire infinite wire है. यहाँ पे पूरा everywhere current is flowing. Infinite wire. So for infinite wire, what do you do? For infinite wire, you take the angles to be theta and theta. So if you see the angle for shown for an infinite wire, the angle shown here, if you're going chota wire hai, so angle chota hoga. As the length keeps increasing, this angle will also keep increasing. Until this is infinitely long, this will almost become parallel. These both will become parallel wires. Both will become parallel because it is not in. I'm just showing this to dramatize it, but otherwise it will become parallel to each other. So angle theta will become equal to 90 degrees. So you can directly apply the formula. So field kitna hoga? Field will be mu naught I, yes, distance a मान लो, by 4 pi a into sin 90 plus sin 90. इसका आंसर कितना है? mu naught I by 4 pi a into 2, which is equal to, which implies b will be equal to mu naught I by 2 pi a. ये बहुत अच्छा inference है. You can remember this inference for other calculations and other problems also. It's a very useful method. You can either remember this mu naught I by 4 pi into sin phi 1 plus sin phi 2, mu naught by 4 pi a you can either use this, or from this derivation you can use this also. Understood? So this is about magnetic field due to current carrying wire. Due to semi-infinite current carrying wire, अब मुझे चाहिए. Now semi-infinite means from this point it is perpendicular like this, and this is going to infinity. तो ये एंगल थीटा 1 and 90 डिग्री हो गया, बट दूसरा एंड कितना है? दूसरा एंड यहीं पे रुक गया ना. दूसरा एंड इज स्टक हियर. So which means from this you will get phi 1 will be equal to 90 degrees, but phi 2 will be equal to 0 degrees. This is what you have to find, guys. I hope it's clear for you to understand what is 90, how to find angles between the two vectors. One angle will be 0, the other angle will be 90. How do you find it? And we are discussing here. Alright, so I'll apply this formula now, because see, you sit at a point, everywhere you sit at the point and see how much angle the wire is making with your view. मान लो ये पॉइंट P इधर है तो अलग होता सिनेरियो, यहाँ पे एंगल थीटा 1 बन जाता, यहाँ पे थीटा 2 इज इक्वल टू 90 लिख सकते हैं. बट इफ दिस इज द पॉइंट हियर, द पॉइंट इज नॉट देयर, इट इज हियर. तो यहाँ से अगर इफ यू सी एग्जैक्टली ड्रॉप ए परपेंडिकुलर, तो हाउ टू फाइंड एंगल? लेट मी एक्सप्लेन वन थिंग. हाउ टू फाइंड एंगल? आई विल गिव यू अ वेरी नाइस ट्रिक हियर. एंगल्स phi 1 and phi 2. First step is drop a perpendicular. First step is drop a perpendicular. Next, below perpendicular is negative, and above perpendicular is positive. बस और कुछ जरूरत नहीं है. इट्स ऑल बिलो परपेंडिकुलर यू विल गेट माइनस थीटा, above perpendicular you will take plus theta, and you will eventually solve off using sin phi 1 plus sin phi 2. तो मतलब यहाँ पे ऐसा है तो phi 2 नेगेटिव, phi 2 is phi 2 should be negative. गेटिंग इट? तो इसमें और प्रॉब्लम सॉल्व करेंगे और अच्छा इजी हो जाएगा. तो इसमें कितना आ जाएगा वैल्यू? द फील्ड विल बी इक्वल टू म्यू नॉट आई बाई 4 pi a into sin 90, which is simple. Mu naught I by 4 pi. This is the field due to एक semi-infinite wire. तो यहाँ पे angles पढ़ना बहुत important है. So give me, I will just give you how to find angles. Without any problem, मतलब very simple हो जाएगा. ठीक है. तो ऐसा है मगर वायर, मान लो यहाँ पे ऐसा है. Let's take a strong long wire. Just no confusion, just take a long wire. I'll take different points. I will take point P1 here. Drop a perpendicular. Only the lower end is possible, right? So here I will directly get, if this angle is phi 1, I will directly get mu naught I by 4 pi a into sin phi 1 directly. One should be below, one should be above. One thing you have to understand is one angle should be below and other above. Then only you can use this formula, mu naught I by 4 pi a into sin phi 1 plus sin phi 2. ये जो भी जितनी भी बार लिख रहा हूँ, this is very important because I want you to remember it. this formula where when phi1 and phi2 should be opposite sides. Opposite sides. If they are same side, if phi1 and phi2 are along same side, then field will be mu naught I by 4 pi a into sin phi1 minus sin phi2. Simple. Clear? Just phi1 phi2 एक ऊपर होना है एक नीचे होना है बस. That is all I need. So let's take another point P here. So here let's take the angles are let's take theta 1 and theta 2. So here field will be mu naught I by 4 pi a into sin theta 1 plus sin theta 2. Got it? And at this particular point, let's take point Q here, where this angle is alpha 1 and this angle is alpha 2. This whole angle is alpha 1 and this small angle is alpha 2. Now if you observe, both of them are along same side. If you observe here, both alpha 1 and alpha 2 are along same side. तो अब यहाँ पे फील्ड कितना होगा? Field at Q will be equal to mu naught I by 4 pi a into sin alpha 2 minus sin alpha 1 minus sin alpha 2. I hope this is adequately clear to you guys. Same side matlab subtract kar do, different side matlab you have to just add them. It's that simple. No need to take too much confusion there. So this is how we solve it. Anyone who wants to note this down, just pause this video and note it down. All right. Next, the field due to a current carrying wire at P. अब ये question solve करते हैं. All right. This distance. अब यहाँ पे there are multiple issues here. Multiple issues. First thing you have to find the perpendicular distance. R perpendicular will be how much? R perpendicular, if you see this triangle here, R perpendicular will be equal to A into cos theta, which is also A cos theta. Okay, the perpendicular distance we found out. And I value is given as I. And phi 1 is taken as minus 30 degrees. क्योंकि ये ऊपर है. अब phi 1 देख लो, ऊपर वाला देख लो. Phi 1 is 60 degrees on top. But phi 2 is in the opposite direction. No, it's also on top. So काउंटर क्लॉकवाइज ढूंढना है तो ऐसे लिख सकते हो कि टोटल एंगल इज 330. यू कैन आइदर राइट 330 डिग्रीज और यू कैन आल्सो सी इट इज गोइंग अगेन इन क्लॉकवाइज डायरेक्शन. सो आई विल राइट minus 30 डिग्री. सिंपल है, लॉजिकली सोच लो. अगर लेंथ ऑफ वायर ज्यादा होगा, इफ इट इज कवरिंग मोर एंगल, मोर फील्ड विल बी देयर. इफ इट इज कवरिंग लेस एंगल, लेस फील्ड विल बी देयर. सो सपोज इट्स स्टार्टिंग फ्रॉम 30 एंड फिनिशिंग एट 60, यू हैव टू सबट्रैक्ट बोथ ना. बहुत इंट्यूटिव है ये. सो सिंपल, ऐसा एक वायर ले लो और ऐसा एक वायर ले लो, जबकि यहाँ पे जो एंगल है, यहाँ पे भी सेम एंगल है और यहाँ पे ऐसा है. दीज बोथ आर कमिंग टू सेम एंगल्स. These vertical component angles are same, but this side is same. You know, this side field will be less, here field will be more. You know, here field is more and here field will be less because it's covered, less current is there. So by this logic only we can say here we have to subtract angles, here we have to add angles. बस add angles कुछ नहीं है इसमें. Bingo, got it. So field will be equal to mu naught I by 4 pi into a cos 30 times sin 60 minus sin. उसका वैल्यू कितना आया? म्यू नॉट आई बाई 4 पाई ए इंटू √3/2. तो √3/2 ऊपर हो गया एंड sin 60 इज √3/2 minus 1/2. ये भी हो गया तो ये दोनों कैंसिल हो गए. ये दोनों कैंसिल हो गए. From this you end up getting, you will get mu naught I by 4 pi a √3 into √3 minus. This is it guys. Great explanation, great solution. Simple है ना, समझ में आ गया तुम लोगों को ये. So if you definitely understood this, definitely hit the like button there and subscribe to this channel. So we will have loads of topics to discuss. All right. So next question ये है, ये मजेदार question है. I'm going to give you 1 minute to solve this problem. 2 minutes solve this problem. Those who are viewing this, definitely solve this because this is very tricky. मतलब इस टाइप के मल्टीपल कॉन्सेप्ट, सिंपल लॉजिक बट इट लुक्स कॉम्प्लिकेटेड. इट्स एन इनफाइनाइट वायर स्टार्टिंग एट अ पॉइंट A as shown. Starting at a point A as shown. The field will be how much due to this wire. I'm going to give you 2 minutes guys. आराम से solve करो इसको. वीडियो को पॉज करके भी सॉल्व कर सकते हो तुम. You can also solve it using by pausing the video. Those who are seeing the recorded sessions. And definitely, be it live or recording, I want you guys to share this to everyone in the world, everyone in the country, because this is the need of the hour. Like a lot of students need teachers to help them with solving a lot of problems, and Unacademy has helped a lot of students like that. It's touched millions of students across the country, and I want you guys to help me do that for you too. I want you guys to share this video so that I can help express myself across the entire country. Yes, great job guys. Those who have done it, great job. चलो इस क्वेश्चन को अब हम सॉल्व करेंगे. एकदम all this needs is a little change in perspective. All this needs is a little change in perspective. ठीक है. यहाँ पे अगर तुम देखो तो this wire is going up to infinity, right? तो ये जो इनिशियल एंगल है वो तो 90 रहेगा ही रहेगा. And now I know this angle is 45 degrees and this is the perpendicular. So this angle will also be 45 degrees and this is perpendicular, making this angle 45 degrees. तो इसमें हमें क्या आ गया, phi1 will be equal to 90 degrees, which is infinity, and phi2 is along this same side, so it will be equal to minus 45 degrees because it is on same side. Getting it? It is on the same side, so we are taking this to be 45 minus 45 degrees. And what is the perpendicular distance? It is equal to a into sine 45 degrees, which is equal to a. अब इसमें फील्ड कितना होगा, ये सब्स्टिट्यूट u naught I by 4 pi into r perpendicular is a by root 2 into sine 90 minus sine 45. ये कितना हुआ, mu naught I by 4 pi a into root 2 into 1 minus 1 by root 2, 1 minus 1 by root 2. ये सिंपली हो गया mu naught I by 4 pi a into root 2 minus. So this is great explanation and great theory. So I want you guys to share it everywhere so that we can make this wonderful. Now this is another kind of question. अब इसमें solve. This question is very good question. I'm going to give you 2 minutes so that you can solve this question properly. एक मजेदार question है. Yes, so this is a very good question, guys. So one thing you have to know this question, that there is one wire which is going to infinity like this, and current is flowing upwards, and यहाँ से भी it's going back to infinity, right? So इसमें there are two parts. This part will take as wire 1, this part will take as wire 2, and the total magnetic field will be equal to one magnetic field due to the wire 1 plus magnetic field due to wire 2. So which can also be written as this is wire 1, so I have a current like this, and this is wire 2, and given this angle is 45 degrees. Okay, I think it's not clear in this video. Yeah, it's not given there. This angle is A and this angle is 45 degrees, and this is going to infinity like this. So this plus this is wire 2. The total of these both will be the answer. We know the value for this. You know, one value is coming from 90 degrees, coming from 90 degrees. So we know what phi 1 is 0, but phi 2 is below, right? And it is equal to 90 degrees. So इसमें क्या आ जाएगा? You know what, I by 4 pi a into sine 0 plus 90, which is just sine 90, which is mu naught I by 4 pi a. This is the first due to wire 1. But due to wire 2, if you observe, you have to drop a perpendicular distance. So if this length is a, how much will this be? This will be a sine 45 degrees. And the current is flowing across this entire thing. तो इस साइड इंफिनिटी हो जाएगा, तो ये एंगल 90 डिग्रीज बन जाएगा, पर ये एंगल बाय सीइंग द डायग्राम यू कैन से दिस एंगल इज 40. तो इसमें क्या आएगा, phi 1 will be equal to 90 degrees and phi 2 will be equal to 45, because एक ऊपर है एक नीचे है, one is above one is below. So we are getting phi 1 is 90 and phi 2 is 45. So now we can apply the formula here, mu naught I by 4 pi into r perpendicular, which is a sine 45 into sine 45 plus sine 9. तो ये कितना हुआ, mu naught I by 4 pi a into root 2 हो गया, because sine 45 is 1 by root 2, and you get 1 by root 2 plus 1. So simply you will get mu naught I by 4 pi a into 1 plus root 2. And what is the directions? If you observe directions, everywhere the direction of thumb is pointing same way, so everywhere it is inside. This is inside and this is also inside. So total sum of both of them will be mu naught I by 4 pi a into 1 plus root 2 plus 1, which is equal to 2 plus 2. Direction is it. So this is it, guys. This is a wonderful solution. I hope you like the solution. It's simple. You just divide it into two multiple wires and start solving. All right. अब है now for the next one. अब एक loop के कारण we will find out the current carrying loop. There is a current carrying loop as shown. This loop is carrying current across the entire thing. Okay. So if you observe one thing, across the entire loop, everywhere the direction of current is changing, and as we discussed, we will take direction using right hand curl method. I'll curl my hand in the direction of current, and the direction of thumb will show you curl method. Curl along direction of current and thumb shows direction of field. So this is very important. You can curl method, you can curl along the direction of current, thumb will show the direction of field. So इसमें कितना, what is it, at an angle theta, for any generic angle theta, I'm going to solve this. So what I will do is, at an angle theta, matlab I will take at an angle alpha, I will take a d alpha element. I'll start from here. I will take at an angle alpha, I will take d alpha element. The radius is a. So what is the dl length? Dl element का length होगा, it's r cross theta, right? It's generally it is r into theta, right? Arc length will be equal to radius into angle. So I can also write it as a into d alpha. Getting it? So the total dl will be given by a into d alpha. And what is the length? Separation is always a, it is always fixed, and everything else is fixed. No, the direction is also coming out. Direction is same for every part. If you observe, हर जगह पे direction, इस side current flow है, इस side current flow है, इस side current flow है, इस side current flow है. Every time the direction will always be outwards. The direction of field is always outwards. Direction is always outward for anti-clockwise current. Like we already discussed. हम ये already discuss किए हैं, तो I'm repeating it again. The direction will be ulta for anti-clockwise current. When the current is going in anti-clockwise direction, the direction of field will be outward, which will be a dot. If the direction is clockwise, then it will be inward. ठीक है, उसके बारे में पहले magnitude we'll find out. So dB due to this dl element will be equal to mu naught by 4 pi into I dl, I into a d alpha by r square a square. तो इसका सिंपली क्या हो गया, म्यू नॉट आई बाई 4 pi a into d alpha. If you observe carefully, everything is a constant here. So you just integrate alpha from what is the range of alpha? ये 0 degree से start हो रहा है, theta तक end हो रहा है. So range is from 0 to theta. Substituting it, you will get b total will be equal to, पहले ये सब लिखने पड़े ये. Now integrate. So you get b will be equal to mu naught I by 4 pi a into alpha from 0 to theta. Plus b is equal to mu naught I by 4 pi a into theta. So this is it, guys. This is a very elegant solution. Mast wala solution mil gaya, where theta is the angle made by the arc. So this is a wonderful solution. I hope you like this. Definitely, if you like this, share it everywhere, guys. I want all of you guys to keep sharing this video everywhere, and I want you guys to just be vocal about it, because this is my way of helping the world, and I want you guys to do it like Stalin style. You know Stalin movie, no? So I will tell this video, I will share it to 3 guys. 3 guys share it to 3 other students. You 3 students share it to 3 other students. Each one of you, and it eventually will get a 3 cube, 3 power 4, 3 power 10, 3 power 500. Alright, so ये must formula है. Why did I say it's a must formula? Because due to a loop, if you take a loop of side A, what is the total arc length of a loop? I won't even solve this problem यार, मतलब एकदम सीधा एक formula बता दूंगा तुम लोगों को. So here, if current is flowing in clockwise direction, anti-clockwise direction, the field will be like this. If the current is moving in clockwise direction, then field will be inward. So this is the main concept you have to remember. Current is anti-clockwise, field is outward. Current is clockwise, field is inward. And one more thing we know, due to an arc, field will be equal to mu naught I by 4 pi a into theta, right? Now if it is a loop, for a complete loop, what is the arc length? What is the value of theta? Theta will be 360 degrees or 2 pi radians. We are discussing everything in terms of radians, so ये angle 2 pi radians हो जाएगा. The field will be mu naught I by 4 pi a into 2 pi, which is nothing but mu naught I by 2a. This is it, guys. एकदम simple सा solution है इसका. You can remember this formula, it's very useful. For a loop, field will be equal to mu naught I by 2a. Understood? If a loop has n turns, मान लो n turns, एक loop नहीं है, single loop नहीं, you have a coil like this of n turns. The field due to that will be mu naught into ni by 2a. ठीक है, क्योंकि single loop के कारण one single loop will have 2 pi radians. N loops will have 2n into pi radians. N turns means number of theta will be 2n pi. Applying this, you'll get this. All right. I hope this is clear to you guys. So due to any arc, any relation, let's find out any arc, the angle relation between arc and field. So field clearly in a loop will be proportional to the angle. It's not proportional to sine theta it will be proportional to sine theta for a straight line. Field is proportional to sine theta for straight line. But for loop, in a loop, field is directly proportional to theta. ये याद रख लोगे तो आराम से हो जाएगा. So if it is full circular loop, the field will be mu naught I by 2a. Alright. If it is a half circle or semicircle, like this, in this kind of situations, if it is making a semicircle like this, separation is a. The field will be how much? It will be mu naught I by 4 pi a into pi. So pi and pi will get cancelled. What is the answer you are getting? Mu naught I by 4a. which is exactly half. If you observe, this is exactly half. Similarly, if you take a quadrant circle ले गया जाए, the field will be mu naught I by 4 pi a into pi by 2, which is mu naught I by 8a. If you observe, again this quadrant circle will be half of this. Quadrant circle मतलब एकदम half of a semicircle. To this. Clear? So ऐसे any angle you can use this logic and you can get a very nice useful logic, a useful formula. So you can simply say field due to an arc of theta radians will be b due to full loop into theta by 2 pi. Unitary method काम आएगा यहाँ पे. It is unitary method will work. That is one very useful trick I can tell you. All right. अब यहाँ पे एक सिंपल सा क्वेश्चन करते हैं before we call it off for today and we can go to we can continue this tomorrow. The magnetic field due to current carrying loop as shown in the figure O is 0. Then so the field at O is 0 is given. So अब इसमें दोनों साइड का फील्ड करेंगे. Let's take one loop and second loop. Due to loop 1, field will be B1 will be equal to mu naught into I by 2 R1, I1 by 2 R1, and the direction is it is going clockwise, so it will be inside. And similarly, due to loop 2, if you see, B2 will be equal to kitna mu naught into ये current kitna hai I2. The current is I2 and 2 by 2 times the radius is R2, and this time it's going counterclockwise, so this is clockwise and this is anti-clock. So in dono ko the directions of both of them are opposite. So when you add both of them, you directly write off mu naught I1 by 2 R1 minus mu naught I2 by 2 R2. The total field. And the direction, since we are taking this upper one as positive, we will take this direction to be negative. All right. So if this is equal to 0, which implies mu naught I1 by 2 R1 is equal to mu naught I2 by 2 R2. So this is the advantage of leaving mu naughts and everything in a simple method, because it will all cancel out. You will get I1 by R1 will be equal to I2 by. So this is it, guys. So that's all for today. All right. So we will solve more problems in the coming classes tomorrow and so on. So until next time, I don't know by mistake this came. See you guys. Definitely problems karenge in the next class. So see you then. All right. Good night, and all of you happy Diwali.